The divergence test is like a really quick way to see if a series is diverging, or it can also be inconclusive. So here we have, let's just say we have a series. So this right over here, this is starting from n, capital N, to infinity for a of n. Now, as our n value approaches infinity, aka the term that we're on is sort of approaching infinity, if a of n is not equal to 0, it's going to be diverging. Otherwise, if a of n is equal to 0, it's inconclusive, meaning that it could diverge or it could converge. All right. Now, let's do an example. Let's say if we have this series right over here. All right. Now, as our n value gets bigger, what happens? When n is equal to 1, we have 2. When n is equal to 2, we have 4. When n is equal to 3, 2 to the third power is 8. Right? So you kind of see the pattern here. Plus 16, plus 32, plus 64. All right. So you can see how as our terms get bigger, right? As our n value essentially gets bigger, right? As our n value gets higher, the term that we are essentially on, right? The value of that term, it's going to get bigger and bigger and bigger. So the way I represent this is, as our n value essentially gets bigger and bigger and bigger, all the way up to essentially infinity, well, our 2 to the n term right over here is going to approach. It's going to approach infinity. Notice how this infinity is, of course, not equal to 0, right? So therefore, this series is going to diverge. And this makes sense, right? Think about it. If the term that you're on keeps getting bigger and bigger and bigger, right? The term that I'm constantly on, as I move from n is equal to 1 to n is equal to 2 to n is equal to 3, if I'm moving along these terms, and my value is just keeps on getting bigger and bigger and bigger, then if I try to add all of them up, well, then this value right over here is just going to get bigger and bigger and bigger, right? Because my terms get bigger and bigger and bigger. So if I try to sum all of these terms right up right over here, it's going to start approaching infinity, right? It's not going to converge to a specific value. It's going to diverge because my terms keep getting bigger and bigger, and well, that's going to lead to it diverging, right? So this divergence test is, pretty useful because, it's a pretty quick test that you can do. You just have to see if your terms are getting bigger and bigger. If you're adding up bigger and bigger terms, well, it's diverging, right? If you try to add all of them up, it's just going to get a bigger and bigger value, so it's going to diverge. Now, let's say if I have this series right over here. Now, when n is equal to 1, well, we have 1 divided by 1 plus 1, which is 2. When n is equal to 2, we have 2 divided by 2 plus 1, which is 3. When n is equal to 3, we have 3 divided by 3 plus 1, which is 4. So notice how as my n value sort of increases, right, as our n value increases, well, the value for my term also increases. So I'm essentially adding up bigger and bigger and bigger values, right? Because 2/3 is greater than 1/2 and 3/4 is greater than 2/3. So if I'm adding up bigger and bigger and bigger values all the way up to infinity, well, then all of these summed up should be essentially infinity, right? So my series is going to diverge, right? Because it's not going to add up to a fixed value. It's just going to keep on getting bigger. And this is essentially the logic for, well, this test right over here. What I'm essentially going to do is I'm going to say, okay, the limit as n approaches infinity. So as my terms get bigger and bigger and bigger, well, what is in this case n divided by n plus 1 approaching, right? What is this approaching as our n value gets bigger and bigger? Now, the sort of shortcut way to do this is you just want to focus on the biggest terms. All right, because at the end of the day, if our n value is getting to a very, very big number, this plus 1 right over here isn't really going to do anything, right? So you can kind of just ignore this plus 1, if you will. And then so as n approaches infinity of n divided by n, well, n divided by n is just going to be equal to 1. Notice how 1 is not equal to 0. Therefore, my series will diverge. All right, the other way to do this, maybe if you were doing this on a test, is maybe you would probably just divide the top and the bottom of this by n divided by n. When you do divide the top and the bottom by n divided by n, you get this, right? Because n divided by n gives you 1, n divided by n here also gives you 1, and 1 divided by n gives you 1 divided by n. Now, as n approaches infinity, this term right over here is going to approach 0, right? Imagine if you have 1 divided by n, and your n value keeps getting bigger and bigger. So you have 1 over 3, then it turns into 1 over 5, then 1 over 7, then 1 over 9, then 1 over 100, right? So our n value keeps getting bigger and bigger. And notice how if our denominator keeps on getting bigger and bigger, the actual value itself is getting smaller and smaller to the point where it's essentially approaching 0. Therefore, 1 over n is going to approach 0, as n approaches infinity. So we just have 1 divided by 1, which is 1. We come up with the same answer as we did before. So this is also going to diverge, right? Now let's say that if we have this series right over here, this is going to be the sum from n is equal to 1 to infinity of 1 divided by n. Now if I actually plot all of this out, right? So when n is equal to 1, this is 1. N is equal to 2, that's 1/2. N is equal to 3, that's 1/3. And you can see the pattern, right? So notice how my terms are getting smaller and smaller as my n value increases. And therefore, if I use this test right over here, it wouldn't actually tell me anything. It could be convergent, it could be divergent. If your values are getting smaller and smaller, it could be either convergent or divergent. It doesn't actually tell you anything. All right, let's actually prove this using the divergence test. So I'm just going to do the same thing I did before. This is going to be the limit as my n value approaches infinity for my thing 1 over n. If n approaches infinity and n is in the denominator, well, this value is just going to approach 0, right? And remember, when your limit approaches 0, you don't know. All right, it could be either. It turns out that this series right over here actually diverges. All right, and the way you find out that this series diverges is you use different tests. So you don't use the divergence test. Think of that divergence test as like kind of like the first barrier, kind of to see if something's divergent or not. If you get this value right over here, where you don't know, where a of n is equal to 0, and well, it doesn't really tell you anything, you have to use different tests. So if you reach this barrier right over here, use a different test. Use different test. All right. It actually turns out that if you use a different test, you'll actually find out that this limit, or this series right over here, it actually diverges, which is pretty cool, right? I mean, think about it, right? You have 1, 1/2, 1, 1, and then 1/2, and then 1/3, and 1/4. So you see how your values are getting smaller and smaller. Yet, if you do this for until infinity, and you add all of these values up, it's actually going to approach infinity. The value is just going to keep getting bigger and bigger and bigger. And that might be a little crazy to you guys because, I mean, if your value is getting smaller and smaller, you would expect that if you add all of these up, it would approach some value, but it actually diverges, which is pretty cool.